Good morning, students. After chapter motion, our next chapter is the force and the laws of motion. In the previous chapter, you studied about various kinds of motion and the equations related to the motion, that is, the three equations related to the motion. Now, whenever an object is moving, there is some force acting on that object that makes the object to move. So in this chapter we'll study about the various forces acting on an object when it is in motion and various laws related to the forces acting on the object. So before going further, let us discuss what is force. So you must have studied that a basic push or pull is known as force. That is, whenever we are pushing an object or pulling an object, we are applying force on that object. But force is basically an external effort which may move a body which is at rest, or it may stop a moving body which is in motion. It can control the speed of moving body, or it can change the direction of moving body. It can also change the shape and size of the body. So it is not just the push and pull. So many effects are seen after applying force on a particular body. So what are the effects we are observing after application of force? Force can move a body which is at rest. Number 2, force can stop a moving body. Number 3, force can change the speed of a moving body. Force can change the direction of a moving body, and the force can change the shape and size of a body. And there are so many examples in our day-to-day life where we can see all these effects. So whenever an object is at rest, we need to apply force. Whenever an object is moving, we need to apply some force. Like, consider this case. This goalkeeper is applying the force in order to stop the motion of the ball. So the goalkeeper needs to apply force in order to stop the moving ball. So here force is applied to make motion into rest. Next case, in this a cyclist is applying force by pedaling the cycle so that it can move. So there one case is when it is applying force on pedal, the cycle is moving from rest. Another case, when the cyclist is applying brake, in that case he is restricting the motion and coming to the rest position. In this example, a batsman is applying force in order to hit the ball. Again, a force is applied. Here the ball is already in motion, but the batsman is applying force in order to change the speed and direction of the ball. In this case, we are applying force on the dough in order to make the chapatis. So the force is again applied. In this case, we are changing the shape of dough. In this case, the person is applying force on this standing car in order to make in motion. So there are so many examples in our daily life where we apply force in order to make the object move from rest, from motion to rest, or to change the direction, or to change the speed. Now this is what we say force. Now there are two types of forces exist in nature. They are the balanced and unbalanced forces. Let us first consider the balanced forces. whenever two forces acting on a body in opposite direction, and if they are equal to each other, then the resultant force acting on the body is zero, and such forces are called the balance forces. Now these balance forces cannot change the state of rest or motion of the body, because the two forces acting on each other are equal, but the directions of applied forces are opposite. So one is acting from left, another is acting from right. They are applying the force equally on an object. In that case, if the object is at rest, it remains at rest, and if it is in motion, it will continue to be in that motion. And you can consider this figure. There are two forces, F1 and F2. Both are acting opposite to each other, and here it is given that F1 and F2 are equal. So in this case, the object remains in its state and it will not move. Now let us consider what are unbalanced forces. As compared to the previous case, if we are considering two forces acting on a body in opposite direction, and if one of the force is greater than the other, in that case there will be some resultant force acting on the body. It means that resultant force is not zero in this case, and it is unbalancing the system. It will make the object to move or make the object to comes to rest. So unbalanced forces changes the state of rest or the uniform motion of the body. And you can consider here in this case, there are two forces acting on this block, F1 and an F2, and it is given that the force F1 is greater than F2. So in which direction the force F1 is acting, that will make the object to move in that particular direction. Hence this force F1 will dominate in this case. Now we had considered two cases, one for the balanced force, another for the unbalanced forces. This object is lying on any surface and two forces are acting on this. Now there is a force which is in picture, that is due to the contact between the two surfaces. That is, one is the surface of the object and another is the surface of this base over which the object is placed. So that particular force is known as the force of friction. Now this force of friction acts opposite to the direction of force applied. So force of friction is force which opposes the relative motion of an object over a surface. Why the term relative? Because the surface is at rest and object over that surface is in motion. So there is a relative motion between the base and that object. So this force opposes the motion of the object over the surface. Let us consider a case over here. We are having a block which is lying on any surface. We are applying force, that is a pushing force. This force makes this object to move forward, but the force of friction comes in play and it acts opposite to the direction of that pushing force and makes the object to comes to rest. It opposes the relative motion of this block over the surface. Okay, so if an object with uniform motion will continue to move with uniform motion if force acting on it, whether the pushing force and the frictional force, both the forces are balanced, so the object will be either in rest or of uniform motion. But if an unbalanced force act on the moving body, then it will change its speed or direction or the state of rest. So let us consider an example that a ball is rolling on ground and it gradually slows down and comes to a stop due to the force of friction. So the force of friction comes in play when the ball is rolling over the ground. Now this force of friction opposes the motion of ball on the ground. Hence, if the unbalanced force is removed, then it will continue to be moved with the speed it has acquired till then. So if no force of friction exists in nature, in that case every object will be in their original state. If the object is at rest, it will remain at rest. If the object is in motion, it will continue to be moved in motion along that particular direction. Let us consider another example also, in which if the person stop pedaling the bicycle, in that case the bicycle gradually slows down and comes to stop due to the force of friction. So these are the examples and applications of the force of friction. Now the force of friction is necessary evil. It is required in our life. If this force of friction is not present, in that case we are not able to walk on ground, on floor, because this force of friction is binding our feet to the ground and we are able to move. If this force will be absent, in that case we definitely fall to the ground. The surface of the floor or ground become very slippery. So this force of friction is very necessary. This force of friction makes the tire to move over the road. Otherwise the tire will slip. Your bike or the car will skid in case the friction is not present between the contact of the tire or the road. Now after the force of friction, let us move to the basic concept of what force is. So a great physicist, Galilei explained the concept of force using an experiment. He considered the motion of a ball over the inclined plane. He took two inclined planes with same angle of inclination, and he observed that when a ball rolls down an inclined plane, its velocity increases due to the effect of gravity, and when it goes up on the second inclined plane, in that case its velocity decreases. If the inclination of both the planes are equal, then the marble ball will reach the same height when it roll down and roll up. But if we consider a case in which we are changing the inclination, in that case what Galileo observed, that if the inclination of second plane is decreased, the ball will travel more distance to reach the original height. Again, if we further decrease the inclination, in that case the ball will again travel more distance in order to reach the original height. And if the inclination of second plane is made horizontal, in that case the marble will travel forever and try to reach the same height. So what we are observing, that an unbalanced force is required to change the motion of the marble, but no force is needed to sustain the uniform motion of the marble. So this is the ideal case which Galileo considered. But in actual practice we know that for the horizontal plane, the ball will comes to rest automatically after its whole energy get dissipated. So Newton used this Galileo's observation in order to define the various laws of motion, which are known as Newton's laws of motion. So basically there are three laws of motion. First one is Newton's first law of motion, which is also known as law of inertia. Newton's second law of motion explains the force or gives the definition of applied force in terms of mass and acceleration of the object. And Newton's third law of motion explains the effect, that is action and reaction of an applied force. That is, for every action there is equal and opposite reaction. So let us first consider the case of Newton's first law of motion. According to Newton's first law of motion, an object will remain in a state of rest or in state of uniform motion along a straight line unless or until some external force is applied on that object. So what it explains? The object at rest will remain at rest and the object in motion will remain in state of motion. So in order to change the state, we need to apply some force, that is some unbalanced force. So with this Newton first law of motion, there is another concept which comes in picture, that is known as the inertia. So what this inertia is? Basically, inertia is inherent tendency. It is a natural tendency of every object to remain in the state of rest or in motion or in a particular direction. So this is inherent tendency, and this is the reason why the first law of motion is also known as the law of inertia. So in order to break the inertia, we need to apply some external force. So let us consider an example that we are having a glass filled with water and a cardboard or a paper is placed over that and a coin is lying on that paper. Now, in order to understand the concept of inertia, let us hit this cardboard with some force, and what we observe that the paper or the cardboard fly off and the coin fell down into the glass. Why it is happening? Why the coin is also not moving with that cardboard? This is because of inertia. Basically, we applied force on the paper or the cardboard, but the coin was at rest. So it was the tendency of the coin to remain in the state of rest unless some force is applied on that coin. So we applied force on paper, the paper flew away, but the coin fell down because of this inertia. So there are so many examples in our day-to-day life of inertia. So before understanding the examples, let us understand the types of inertia. So basically three types of inertia exist. First is inertia of rest. So according to inertia of rest, a body remains in state of rest unless or until some external force is applied on it to change its state of rest. So in order to make the object in motion, we need to apply force. Next is inertia of motion. So an object will remain in state of motion unless or until some external force is applied on that object. So here the type of motion is along a straight line. So object will remain in motion along the straight line unless some external force is applied in order to make the object comes to rest, or in order to make the object change the direction. So this is inertia of motion. Now next is inertia of direction. So whenever an object is moving in a particular direction, in that case we need to apply some force to make the object comes to rest or move along a straight direction or move along any other direction. So inertia of direction is states that a body remains in its state of motion along a particular direction unless or until some external force is applied to it in order to change its motion along that particular direction. So let us consider few examples of inertia. If a striker while playing a carom hits a pile of coin on carom board, the lowest coin moves out due to inertia of rest. The other coins fell down. So we are applying force on the lowest coin and the coin move forward because of applied force. But other coins above this coin are still in state of rest, and because of that they fell down. Next is if we are standing in a bus and the bus begins to move suddenly, we tend to fall backward. Why it is happening? Because whenever we are standing in a bus and bus is at rest, so we are also in rest position with that bus. But if the bus is starting suddenly, our lower portion, our feet which are in contact with bus comes in motion, but our upper portion is still in rest, and because of that we feel a backward jerk. So this is because of inertia of rest. Again, let us consider an example when we are traveling in a car and the driver suddenly applies the brake. In that case we feel to move forward. Why it is so? This is because the car is in motion, and because of that we are sitting in that car and we are in motion. When sudden brakes are applied, in that case our lower portion which is in contact with the car seat comes to rest, but our upper portion is still in motion, and because of that applied brake we tend to fall forward. And this is an example of inertia of motion. Let us consider a case that when we are traveling in a car and the driver suddenly takes a sharp turn, we tend to fall in opposite direction of the movement of car. Why it is so? Because of the inertia of direction. So our tendency is to move in the original or the previous direction, but after the application of force we try to remain in our previous state and the car is moving in other state, and because of that we feel a force in opposite direction. So there are so many number of examples from our day-to-day life where we feel the examples of inertia, like whenever we are hitting a carpet in order to clean that carpet, what we observe that after beating that carpet the dust comes down, fall on the ground. Why it is so? Because we are applying force on the blanket or the carpet, so that force make the blanket or the carpet to move in forward direction, but the dust particles are still at rest, and because of that they fall down. Another example is whenever we are applying force on any tree, suppose the mango tree. So if the mangoes are ripened, in that case what happens? Whenever we are applied force on any plant or tree, the flowers or the fruit fell down. Why it is so? Because we are providing motion to that tree, to the stems, but the fruit or flower are still at rest, and because of inertia of rest they fall down. So there are n number of examples for this inertia of rest, inertia of motion, and inertia of direction. Now, after this inertia, let us consider what is the cause of this inertia. As we know that a body at rest continued to be in state of rest or motion or direction, this is known as inertia. Now, what is the factor which provides this inertia? So, the mass of the body is the measure of its inertia. More is the mass, more is the inertia, and more we need to apply the state of that particular object. Less is mass, less is inertia, and less is the force applied. So, in order to make the heavy object to move, we need to apply more force, and that is directly related to the mass of the object. Hence, we can say that inertia of a body is measured by the magnitude of force required to change the state of the body, and the force required to change the state of a heavier body is more than the force required to change the state of a lighter body. And this is because the mass of heavier body is more than the mass of lighter body. So you can see from this figure that the person is applying force over an object which is fragile, and that's why very light as compared to the weight of that object. The weight of this object is 32 and the person weight might be 60 or 70. So the force applied by the person is more on this object, and the person is easy to move this object. If we consider another case, in this case the weight of person is less and the size or mass of the object is more. So in this case more force is required to make this object move. So hence the mass of a body is the measure of its inertia.